Have you ever pondered upon the intriguing concept of inverse trigonometric functions? Well, sit back and relax because today we're going to delve deep into the world of trigonometry and its inverses. Firstly, what exactly are these inverse trigonometric functions? They're the inverses of the trigonometric functions you're probably already familiar with: sine, cosine, and tangent. Just as the square root is the inverse function of squaring, the inverse trigonometric functions are the inverses of the sine, cosine, and tangent functions. Let's take a look at the sine function, for instance. It takes an angle and gives the length of the side opposite that angle in a right triangle. The inverse sine function, often written as sin circumflex 1 or arcsin, does exactly the opposite. It takes the ratio of the opposite side to the hypotenuse and gives you the angle that corresponds to that ratio. The same applies to the inverse cosine and inverse tangent functions. Now, a crucial aspect to understand about inverse trigonometric functions is their domain and range. The domain of a function is the set of all possible input values, while the range is the set of all possible output values. For the inverse sine and inverse cosine functions, the domain is the interval from -1 to 1, while the range is from 0 to pi for inverse cosine and from -pi/2 to pi/2 for inverse sine. For the inverse tangent function, the domain is all real numbers and the range is from -pi/2 to pi/2. Moving on to the graphs of these inverse functions. The graph of the inverse sine function, for instance, is a reflection of the graph of the sine function in the line Vy equals sine x. The graph starts at -pi/2 and ends at pi/2, with the x-axis representing the ratio of the side lengths and the y-axis representing the angles. Similar reflections occur for the graphs of the inverse cosine and inverse tangent functions. So, to summarize, inverse trigonometric functions are the inverses of the sine, cosine, and tangent functions. They take in a ratio of side lengths and output an angle. The domain and range of these functions are crucial to understand, with the domain typically being the interval from -1 to 1, and the range being specific sets of angles for each function. The graphs of these functions are reflections of their respective trigonometric function graphs in the line y equals sine x. And there you have it. A brief yet comprehensive look at inverse trigonometric functions. Whether you're tackling a tough math problem or simply curious about the world of mathematics, understanding inverse trigonometric functions can certainly come in handy. So keep exploring, keep learning, and most importantly, don't fear the math.